In this class, we will study about electric dipole. First, we will see what is a dipole. It is something related to di. So, a dipole is nothing but two equal and opposite charges separated by a small distance. Separated by small distance from each other constitute a dipole. Two equal and opposite charges separated by small distance from each other. We can consider two equal and opposite charges. The magnitudes are same, so if one charge is plus q, the other is minus q. Separated by some distance, let me take it as 2a. Distance of separation is 2a. Now, how to measure strength of this dipole? How to measure the strength? The strength of dipole is measured by its dipole moment. Dipole moment. The magnitude of electric dipole moment, and it is a vector quantity, so it is electric dipole moment is symbolically represented as P. The magnitude of dipole moment is equal to the product of magnitude of either charge and separation between the two charges. P is given by product of magnitude of any one charge Q multiplied by 2a, the distance of separation between them. Magnitude of any one charge multiplied by the distance between the two charges. Its SI unit is coulomb meter. Because I said it is a vector quantity, P is Q into 2a, and it is directed from negative to positive charge. Positive charge. So in the figure we can show it as P as negative to positive charge, dipole moment. Now we know what is electric dipole and how we can measure its strength. Next we will see what is the electric field at any point on the axis of a dipole. We'll find out electric field due to this dipole. We'll see electric field. Find out the electric field at any point on axis of dipole. For this we will consider a dipole plus q minus q I'll write here first. Consider a dipole separated by a distance to A. So we'll consider this. Dipole minus q plus q separated by a distance to A. Now let us say we want to find out the electric field at any point on the axis of dipole. So let me say I want to find out the dipole at some point, say P, on the axis. So my P lies somewhere here. P. So we need to find out the electric field intensity at any point on the axis of electric dipole. And say this distance, the distance of P from the center. So this is the center of dipole. So this distance is A, and this is also A. And let us say the point P is at a distance r from the center. Now we need to find out electric field E at point P. So we can write here, to find electric field intensity at point P. Let point P is at a distance r from the center O. From the point O, or from center O. Now the total electric field will be the vector sum of electric field due to minus q and the electric field due to plus q. The electric field due to plus q is pointing away from it. Let us say take these 2 points as the minus q is at a point A and plus q is at a point B. So I can say the electric field at P due to plus q is E PB, E or EB, which is away from plus q. Similarly, electric field at P due to q minus q at A is EA, and this towards minus q. So total electric field at P is, it is EB difference EA. or I can directly write EB minus EA, because we are very sure EB is greater than EA. The field at B due to plus Q, because plus Q point is nearer to P, so the field due to plus Q will be greater than field due to minus Q. Now field at P due to plus Q, which is equal to EB. So recall the electric field formula: 1 by 4 pi epsilon naught into Q divided by the distance square. What is the distance from B to P? So it is nothing but this distance is R minus A, because P is at a distance R. So this is nothing but R minus A. From figure it is clear. I'll write here. This is R minus A. Similarly, field at P due to minus Q, 1 by 4 pi epsilon naught into Q divided by, now this distance is, this is R, this is A, so the total distance is R plus A. R plus A from A to P. Therefore, net field at P. So here if I am writing vector, so I can write here is away from minus Q, and this is away, sorry, towards plus, away from minus Q, or I can say plus Q, and here we can say towards minus Q. So if you are writing this, then here instead of showing the vector, we can just write the magnitude. One by 4 pi epsilon naught into Q by R plus A whole square. Now we need to simplify this. Take common denominator as R minus A whole square into R plus A square. Now Q divided by 4 pi epsilon naught is common. R plus A whole square minus R minus A whole square divided by R minus A whole square into R plus A whole square. Now simplify this. Q divided by 4 pi epsilon naught into R square plus a square plus 2ar minus r square minus a square plus 2ar divided by r square minus a square whole square. Cancel the common terms. Cancel r square and r square, a square and a square. Q divided by 4 pi epsilon naught into two AR. This is 2AR is 4AR, r square minus a square whole square. So now this 4AR can be written as 2A into 2R into r square minus a square whole square. And we know Q into 2A is nothing but P. So this term Q into 2A is P. I can write Q divided by 4 pi epsilon naught into P into 2R divided by r square minus a square whole square, because P equal to Q into 2A. If R is very greater than A, then this equation becomes, for R very greater than A, the net field at P is Q. Sorry, we don't have Q over here. This is 1. Because Q into 2A we are writing it as P. So it is 1 by 4 pi epsilon naught into 2P into R divided by R to the power 4. Simplify this, 1R will get cancelled. So net field will become equal to 1 by 4 pi epsilon naught into 2P by RQ. So this is the field at P. The field at any point on the axis of dipole is given by 1 by 4 pi epsilon naught into 2P by R cube.